Hello, good morning. So today we are going to see the hashing. It is a basics of hash table, basics of the hashing. That is how we are going to use hash table for hashing the keys into the hash table, how to store keys, how to retrieve keys from the hash table. So let us start with the basic definition of hashing. So we have three definitions here, and they are actually indicating the same logic. So we have just different words in the definitions, and that is for a better understanding. So we have definition one here, which says that hashing refers to the process of generating a fixed size index or location ID from an input key of variable size using the mathematical formulas known as hash functions. So the keys or the values which we are going to store into the hash table, they may be of one digit, two digit, three digits, or maybe any n number of digits having variable size. But when we process them using a hash function, that hash function generates a fixed size index or a location ID of hash table where that key is mapped or stored. Similarly, when we try to retrieve the key from the hash table, we again process the key using hash table and then, sorry, hash function, and then again we get the same location ID from that hash function where the key is present. So now, second definition says that hashing is the process of mapping or storing key or value or record or element into the hash table at the location or index generated by hash function. So again, different words but having the same meaning. Now, in case of third definition, hashing is a popular technique in computer science that involves mapping large data sets to fixed length values by converting a data set of variable size into a data set of fixed size having ability to perform efficient storage and lookup operations. So as we know, hashing is better than linear search and binary search, as linear search provides you the time complexity of O of n in the worst case. In case of binary search, it is reduced to O of log n. Now hashing is the technique that if we store the keys into the unique locations provided by hash functions in the hash table, so we can store them or retrieve those keys or values in O of one time if that hash table is collision free. Okay, so provided that hash table should be collision free. So O of 1 is the constant time complexity which is provided by hashing for searching operation or lookup operation for the keys or values. So let us see the example. So see, we have these keys here like 12, 18, then 367, 556, 1090. So you can see we have the keys of variable sizes, right, as we have seen in the definition. Now these keys are variable sizes. Now we are processing them using the hash function. Now this hash function is a division method which says key mod 10. So this 10 is nothing but the table size. So we can have here table size, you can see index 0 to 9. So there are total 10 locations in the hash table. So these 10 locations are nothing but the 10 buckets where a bucket can store a single key or value. So see, if we map 12, so 12 mod 10. So this is how we map 12 mod 10. So it gives us the index 2. When we map 18 mod 10, it will give us index 8. When we map 367 mod 10, it will give us index 7. Similarly, if I map 1090, it will give me the index 0. So see, even if the keys are of variable sizes, 2 digits, 3 digits, 4 digits, but the index generated or the location ID generated is of fixed size. So that is what mentioned in the hashing definition, okay, given above, right? So see, we have mapped 12 to the location 2, 18 to location 8, 367 to location 7, 556 to location 6, and 1090 mod 10 equal to 0. So 1090 is mapped to the location index 0. Okay, so this is how hashing works. So in hashing we have keys, we have hash function, and we have hash table. So hash table is nothing but an array of number of locations. So we use that number of locations, that is size of hash table, in the hash function to map the keys into the hash table. Okay, so this is how we store the keys. Similarly, if I want to retrieve or look up for suppose 12, so how I will look up? I will again process 12, which is the key to be searched, 12 mod 10. So I will get 2, and then I find 12 at location 2. See. So similar operation is done for retrieval also. So storage and retrieval can be done in 1 unit of time, in O of 1 time, if there is no collision in the hash table. So we'll see what is collision in the further minutes. So see, initially key. What is a key? A key can be anything. So it can be a string, it can be integer, and this is the data or part of the data to be stored inside the hash table, and it is fed as input to the hash function. This is the key. So it can be integer, string, it can be a part of data, right? Now after this, what is the hash function? The hash function is the mathematical formula which processes this key to generate a hash code or hash key. So that is nothing but an index of hash table where that key will be stored. Now see, what is hash key? Hash key is nothing but the hash value or hash code generated by hash function by processing a variable sized key, and the hash code generated is the fixed size numerical or alphanumeric code. So that is hash key. Now what is hash table? It is an array which stores the data in an associative manner where each data value has its own unique index or location generated by hash function. So hash function is a deterministic hash function where it always produces the same index or location address for the given key, whether you are checking it or generating it while storage or during retrieval. So it will produce the same location address for that particular key. So that is why it is said that hash table is an array where each key or value to be stored or which is stored has its own unique index. Now, next is bucket. So what is a bucket? So bucket is the location of hash table. So in case of like there are two types of hashing, open hashing and closed hashing. So in case of closed hashing, this bucket can store one data or element or one key. So it has a size to store one key or one element or one record. Okay. In case of open hashing, it can store multiple records or multiple keys by using a separate chaining method. So there is these multiple keys are chained together if there is a collision. So bucket is nothing but a location of hash table where the keys are stored. So these buckets are having unique ID and they are used to map keys or look up for keys. So number of buckets in the hash table are equal to the size of that hash table array. Now next is synonyms. What is synonyms? Synonym is there is a possibility that maybe two or more than two keys or elements are having the address of the same bucket or location of hash table. So when we process suppose 12 mod 10, so it gives us 2. When we process 42 mod 10, it also gives us 2. 362 mod 10, it also gives us 2. So when we process the number of keys using the hash function, And for those keys, if the hash function is generating the same bucket or location ID, so those number of keys are called as synonyms. Those number of keys are called as synonyms. So here 12, 42, 362 are synonyms. Now next is collision. So as the situation where a newly inserted key or data is mapping to an already occupied location or bucket of a hash table. So as the bucket is already full, it leads to collision for new key, right? So if we are trying to insert a new key or we are trying to map the new key into the bucket which is already full, so that is called as collision. So like here, we are storing 12 at location 2. Now after that, if we are trying to store 362 on the same location, that leads to collision. Now after that, we have a load factor. What is the load factor? How many keys are present in the hash table out of the size of hash table? So the number of keys present divided by number of locations in the hash table. So that gives us load factor, and that is necessary to decide when to increase the size of hash table. Because if the number of keys or the load factor in the hash table increases beyond certain like 75%, 80%, so that leads to a more number of collisions or more number of probing mechanisms. So we can avoid this if we want to maintain the get and put operation complexity O of 1. So we have to increase the size. So that is increase the size of hash table and then again map the existing keys into the new hash table, and that is called as rehashing. So rehashing is the process of increasing the size of hash table and redistributing the elements to new buckets based on their new hash values. It is done to improve the performance of hash tables, map and lookup operations, as well as to prevent collisions caused by a high load factor. Now, we have one more terminology, that is types of hashing. So types of hashing are open hashing and closed hashing. So as I said, in case of closed hashing, the bucket size is 1, where we can store only one data element. In case of closed hashing, we can store one or more elements. So bucket size is dynamic. So the data structure used in case of closed hashing is array. Whereas in case of open hashing, we have to use array as well as linked list. So it's a dynamic way of storing the keys or values. So it needs the use of linked list. Now the type of memory. So as I said, closed hashing is static and then open hashing is dynamic. In case of collision, closed hashing uses a collision resolution strategy called as open addressing. So we find an alternate empty location into the hash table by using linear probing, quadratic probing, or double hashing. So we will use one of the technique to find alternate location and then we'll store the key or value which led to the collision. Now, in case of open hashing, we use separate chaining method where we will maintain a separate linked list for each bucket. So, if there is a collision, then the other keys which are mapped to the same bucket are chained together into the linked list. Now, in case of efficiency, closed hashing is less efficient as the table becomes full early, which leads to rehashing. And rehashing means again remapping or redistributing the keys into the new hash table, which is a little time consuming. Whereas in case of open hashing, it is more efficient as the keys are mapped to the same location and they are chained together using separate linked list for each bucket. So efficiency in case of time complexity, closed hashing is less efficient, whereas open hashing is more efficient. But in case of space complexity, you can see closed hashing uses only array. So it is more space efficient. Whereas in case of open hashing, we have to use array as well as linked list, allocate memory dynamically. So open hashing is less space efficient. Okay. Now after this, data lookup. So the time complexity for lookup operation or search operation is O of 1 in closed hashing if the hash table is collision free. Otherwise, probing is required to search the element. Now this may increase your time complexity from O of 1 to O of n. Now in case of open hashing, there are separate linked lists maintained for each bucket. So the time complexity for searching or lookup operation will be O of n. That n is equal to the number of nodes into that chain or linked list, or the number of keys stored into that linked list. So this is open hashing and closed hashing. And now this is how the hashing works. So we have input values, we process that value using hash function, and then hash function generates the hash key or hash code or bucket ID where that value is stored. So as you can see, if the hash table is of size 7, having bucket IDs, bucket 0 to bucket 6. So if we have a value 7, so 7 mod table size. So table size is 7. So 7 mod 7 which gives us a bucket ID 0. So 7 is stored into bucket 0. Now 16, for 16 we have 16 mod table size, 16 mod 7. So it gives us bucket ID 2, hash key 2. So 16 will be stored inside second bucket, bucket number 2. Similarly, we will map other keys using the hash function provided. So this is the division method of hash function. We can also use other methods of hash function like multiplication method or double hashing method, like that. So this is the basic terminology for hashing. I hope this is clear. So now I will stop. Enjoy learning of data structures. Thank you.